Okay, today we're going to do 6.1, okay, on the binomial theorem. Okay, binomial theorem is about expanding a plus b to the power of n. So you can see over here, okay, so expanding a plus b to the power of n. But for 6.1 itself, we'll be actually just expanding 1 plus b to the power of n. So this simplifies the expansion a bit. So before I even start on the binomial theorem itself, I'll talk about this French mathematician. Okay, his name is Pascal. So he invented this thing called the Pascal triangle, okay, which is found over here, this honeycomb thingy over here. So basically, it'll begin with the number 1, okay. So then the next level is 1 and 1. Okay, see. Now, how do I get the number for the next level? It's like, it's dependent on the numbers above. So for example, to get this 1 over here, there's nothing there. Here is 0 plus 1. I get a 1 over here. To get this next number here, the 2, I look at the numbers above, here and here. So 1 plus 1 will give me the 2. Similarly, to get this 1 over here, I look above, is 1. There's nothing there. 1 plus 0 gives me a 1. If you focus further, to get this number here, above, okay, is a 0. Above is a 1. 0 plus 1 gives me a 1. Now, to get this hexagon over here, I look above. 2 plus 1 will give me 3. So the bottom numbers are always dependent on the numbers that are above them. For example, how did I get this 10 here? Okay, in the Pascal triangle above, the two numbers above are 6 and 4. So 6 plus 4 gives me a 10, and so on and so forth. So this, right, is known as a Pascal triangle, and this will come into play in a very while with regards to how we actually do the binomial theorem itself. Okay, so today, as I've already mentioned, we are going to do 1 plus b to the power of n. But before we start that, we need to learn about something called n factorial. Okay, so n factorial, if you look right, is this. Okay, they give you in algebra. So n factorial equals to n times n minus 1 times n minus 2, then times dot 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 until you get 3 times 2 times 1. So, and furthermore, we define 0 factorial as being equals to 1. In simple terms, okay, you don't need to worry so much about this. So, in simple terms, it implies this. If I'm doing 4 factorial, okay, so if I want to get 4 factorial, what happens here is this. 4 factorial is 4 times 3 times 2 times 1. You just go all the way until you reach 1, okay? Is 12 times 2, what we get is 24. Okay, similarly, if I'm looking for this expression, 6 factorial, it is, okay, we start with, because it's 6, so we start with 6 times 5 times 4 times 3 times 2 times 1. Just go all the way to 1. 360, we get 720 over here. So that's the meaning of factorial. Can so far? Okay, so now for example 1, okay, what we want, right, is 4 factorial times 3 factorial. So if I'm going for 4 factorial times 3 factorial, so 4 factorial is 4 times 3 times 2 times 1, and 3 factorial is 3 times 2 times 1. We just go all the way to 1 itself. So in this case, what we get is 24 multiplied by 6. We'll get 144. Now, the issue will come when we have algebra. So they do not give you the actual number itself. They give you as n factorial and n minus 1 factorial. So what we can do here is this. Don't worry. First, I start n factorial. So n factorial in the numerator, n times n minus 1 times n minus 2 times n minus 3. We do not know what it is, okay, but never mind. Eventually, you know that we're going to end up with times 3 times 2 times 1, the final few terms. Now we look for a pattern, okay. For example, n minus 1 factorial. N minus 1 factorial will actually give me, first we start with n minus 1, then we go to the next number which is smaller, n minus 2, then we go to n minus 3 times dot 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 all the way until it's 3 times 2 times 1. we start to think to ourselves, what can I actually eliminate? Can eliminate n minus 1, yep. I can eliminate n minus 2, I can eliminate n minus 3, all the terms in between I can eliminate. I eliminate 3, I eliminate 2, I eliminate 1. So if all these are eliminated, what I'm left with is simply n. Hence, n factorial over n minus 1 factorial is simply equals to n. Okay, now please try one, and then I'll give you the answers in a short moment. So I would suggest that you pause a video, take out a piece of paper or use your iPads, okay, and go and attempt to do these two questions. And I'll give you the answers in 3, 2, 1. Let's go. Okay, 11 factorial over 8 factorial. So if we do all the way 11 factorial is 11 times 10 times 9 times 8 all the way until 1. 8 is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So you can see that we can actually eliminate from 8 onwards. We can eliminate from 8 onwards. So if we eliminate all this, all I'm left with is 11 times 10 times 9. It gives me 990. Okay, now this is a modification of the question that we actually covered earlier. So n plus 1 factorial, n factorial I won't go through again. N plus 1 factorial, so we start with n plus 1. The next smallest term, you minus 1, you get n. Next smaller term is n minus 1, n minus 2, all the way until 3, 2, 1. So in this case, what we can actually start to eliminate, right, is n minus 1, n minus 2, all of this, 3 times 2 times 1, 3 times 2 times 1. All that remains is n, n plus 1, and n. So what we have that's remaining is n over n plus 1 times n. What we can do now is to eliminate n, we're left with a 1 above, hence we get 1 over n plus 1. Now, there's this notation n over r, okay, don't say it's over. So what we have here is this, it's actually a function in your calculator. This is known as n choose r. So for example, if I have this 3 and 2, this is known as 3 choose 2. Or for example, I have 7 and 5 in this manner. I write it this way. This is known as 7 choose 5. Basically, it's actually in mathematics, right? If I say 7 choose 5, means that if I have 7 objects, let's say A, B, C, D, E, F, G, I want to choose 5 objects. In how many ways can I choose 5 objects? So I could choose A, B, C, D, E, or I could choose B, D, E, F, G, or I could choose B, C, F, G, and A. So there are many ways to choose 5 objects out of 7, and this is the mathematical way that we can actually calculate 7 choose 5. This can actually be found inside your calculator itself, but let me teach you how to use the what I call the manual way of doing this, and then we can actually work with how we can do this with the calculator. So for example, 8 choose 2. So the book actually defines this n factorial, r factorial, and all. Okay, let me just show you what it is. So for example, I will start with 8 choose 2. So if I want to have 8 choose 2, the easiest way is actually this. If I look at the bottom, is 2. So I just go 2 times 1. Alright? Okay, I just go all the way to 1. So the top the numerator will follow the denominator. There are 2 terms in the denominator, 2 times 1. So if I start with 8, I just go to 7. So I get 56 divided by 2, it is 28. Similarly, 20 choose 4. Same again, we start the denominator. So with the 4, I go 4 times 3 times 2 times 1. Then the numerator will follow 20 times 19 times 18, okay, times 17. So what we have here is 20 times 19 times 18 times 17. I get 116,280 divided by 12 times 2, 24. So 20 choose 4 in this case will actually give me the final answer of 116,280 divided by 24. There are 4845. So basically, you have 20 items to choose from, and you want to choose 4 out of this 20. There are 4,845 ways to choose 4 items out of a total of 20 choices. Okay, now I will do example 3 with you now. So example 3, here is where the issue is slightly compounded. So now instead of having what I call a fixed number like 20 choose 3 or 5 choose 2, now we have n choose 3 and n choose 1. Not to worry, it's a similar idea. For n choose 3, first I work on the denominator, 3 times 2 times 1. Then the numerator will follow. I take n. Then the next smaller term is n minus 1 times n minus 2. Okay, I follow. So there are 3 terms below. So I have 1 term above, 2 term above, and 3 terms above. For the next one, we have n choose 1 is a simple one. So for n choose 1, bottom is just, the denominator is just 1. On top, we follow with 1 term is n. So no need to proceed to n minus 1, n minus 2 is simply n. Now, I divide both sides by n. I can eliminate my n. So I'm left in the numerator n minus 1, n minus 2 over 6 is equals to 5. Then it becomes a question of algebra. N squared minus n minus 2n minus 3n plus 2. I've expanded my numerator. Okay, equals to 6 times 5. I multiply by 6 on both sides of the equation. I get 30. So n squared minus 3n minus 28 is equals to 0. Doing simple calculation, simple factorization rather, I solve for my n value. Okay, for n choose r, okay, we cannot have a negative value. Why? Because as I said, it's like 20 items, you choose 5. You can't choose items from negative 4 items. So hence, right, when we are solving for n choose r questions, the n value must always be an integer, and it must always be a positive integer. Hence, we reject negative 4. So the answer is n equals to 7. Okay, to put into practice what we have just spoke about, please try 3. So do pause the video, use a paper, then use maybe your iPad to try to solve this. And I'll give you the answer in 3, 2, 1. Let's go. Okay, for n choose 5 equals to n choose 3, the answer I have here may seem a bit more complicated, but never mind, let me just help you. Okay, so for n choose 5, we have 5 times 4 times 3 times 2 times 1. Then in my numerator, I got, start with n, okay, times n minus 1, second term, third term, fourth term, and fifth term, like this. For n choose 3, so in my numerator, this is choose 3, 3 times 2 times 1. I start with n times n minus 1, like this. Okay, what I can actually do, okay, down here, all right, is to, I missed one more term, then times n minus 2. There are 3 terms at the numerator, denominator, so there should be 3 terms in the numerator itself. So if you notice, what I can actually start to eliminate here will actually be the n minus 1. You divide on both sides. I can also eliminate n minus 2. I can also eliminate n by dividing both sides by n. So what this simplifies to will be simply n minus 3 times n minus 4. Okay, similarly, all right, 3 times 2 times 1, okay, I can eliminate 3 times 2 times 1, 3 times 2 times 1. So I'm left with over 20 in my denominator is equals to 1. So to solve this, what I get is n squared minus 7n plus 12 equals to 20 minus 8. So what I get is I factorize n minus 8, n plus 1 equals to 0. So my n value is 8 or n equals to negative 1 because the n value has to be a positive integer. Okay, now there is something there's something called a binomial expansion. So basically what this table, which can be found in textbook 6a, is doing is we're expanding 1 plus b to the power of n. So if my n value is 0, okay, 1 plus b to the power of 0, anything to the power of 0 gives you 1. Okay, now if n equals to 1, 1 plus b, I get 1 plus b. Alright, that's what it means by 1 and 1. This is 1 and 1b. Now, we work with 1 plus b squared. So 1 plus b squared is a squared plus 2. 1 times b is b. 2ab is 2 times 1 times b plus b squared. Notice that in this case, you get 1, 2, and 1. So, if you look here, the coefficients are 1, 2, and 1. Similarly, if I work with 1 plus b cubed, if we expand this, what we should get is 1 plus 3b plus 3b squared plus b cubed. So notice the pattern, okay? There is a pattern to these coefficients, then 1, 3, 3, 1. All these actually follow the Pascal triangle itself. So what happens here is this: if I'm trying to expand 1 plus b to the power of 4, okay, if I use my Pascal triangle, you look over here, 1 plus b to the power of 4, 1, 4, 6, 4, 1. How I do this? Here is 1, okay, to get this 4, the two numbers above is 1 plus 3, to get the 6, I get 3 plus 3, to get the 4, I get 3 plus 1. To get this 1, I take 1 plus 0, I get 1. Okay, why don't I just fill in the next level of the Pascal triangle? Here is 1. 1 plus 4 is 5. 6 plus 4 is 10. 6 plus 4 is 10. 4 plus 1 is 5. And it's 1. So if I were to expand, in this case, 1 plus b to the power of 4, I get 1 plus 4b. Notice that my b will be in increasing powers. It becomes 6b squared plus 4b cubed, okay, where I get the 4 is from the Pascal triangle, plus 1b to the power of 4. Similarly, if I expand 1 plus b to the power of 5, I get 1 plus 5b, okay, plus 10b squared. Just notice the pattern, plus 10b cubed, plus 5b to the power of 4, and plus 1b to the power of 5. So that's how the Pascal triangle actually helps us to find the coefficients when I expand this binomial itself. Okay, never mind. Okay, so now if let's say I want to find 7, okay, so 1 plus b to the power of 7, if you look right, the fifth level, okay, of my of Pascal's triangle is 1, 5, 10, 10, 5, 1. Okay, don't worry about this. Don't memorize this. Okay, we will actually give you the what I call the expansion. I'll teach you a simpler way rather. Okay, to find this expansion. So when n equals to 5, from the previous table itself, I got 1, 5, 10, 10, 5, 1, 5, 10, 10, 5, and 1. This is to expand 1 plus b to the power of 5. So this comes from the previous page over here. Now, for n equals to 6, if I have my Pascal triangle, I get 1, 6, 15, 20, 15, 6, and 1. For the 7th level, I get 1, 7, 21, 35, 35, 21, 7, and 1. So now for example 4 itself, what I get is 1 plus b to the power of 7 is, first I get 1, okay, then plus, if you look at the coefficient is 7 and my b is increasing powers, so it's 7b plus 21b squared plus 35b cubed plus 35 to the power of b to the power of 4 plus, if I want to carry on, okay, it will be 21b to the power of 5 plus 7b to the power of 6 plus last one is 1b to the power of 7 down here, this one here. But the question says expand to find the first 5 terms. So 1, 2, 3, 4, 5. I'm done here, so I just put plus dot dot dot. Now, part A says this. Hence, deduce the first 5 terms in ascending powers of b or x in the expression of 1 minus b to the power of 7. So earlier, we have already expanded 1 plus b to the power of 7. So now we are trying to expand 1 minus b to the power of 7. Okay, hence deduce. So here is plus b, we get all of this. So now I'm replacing or substituting plus b with negative b. So I just need to replace all my b terms with negative b. So what I get is 1 plus 7 times negative b plus 21 times negative b squared. The square comes from here, plus 35 times negative b cubed plus 35 times negative b to the power of 4. If I simplify everything, I get 1 minus 7b plus 21b squared plus 35b to the power of 4. Okay, that is for 2a. For 2b, 1 plus 2x to the power of 7. If you can figure this out, I think you have got this idea already. I replace b with negative b in part A. So in part B, what do you think we should be replacing b with? If you compare this and this, if your answer is 2x, then you have gotten an idea here. So what I need to replace is now all my b terms, I replace with 2x. So I get 1 plus 7 times 2x plus 21 times 2x squared plus 35 times 2x cubed plus 35 times 2x to the power of 4 plus dot 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 dot. So if I simplify, this gives me 14x plus 21 times 4x squared will give me 84x squared. 35 times 2x cubed. 2x cubed will give me 8x cubed. So 35 times 8x cubed will give me 280x cubed. And 2x to the power of 4 is 16x to the power of 4 times 35 will give me 560x to the power of 4. That is example 4. Okay, now we do not need to memorize the Pascal triangle. So actually the Pascal triangle can be represented with n choose r. So earlier we have learned about n choose r itself. So now same thing, 1 is 0, 0. So n equals to 1, we have 1 choose 0, 1 choose 1. Then for the second level is 2 choose 0, 2 choose 1, 2 choose 2. Okay, we get 1, 2, 1. Okay, 2 choose 1 is, for example, 2 choose 1, 1, then is 2. 2 over 1 gives you 2. For example, 1, 3, 3, 1, the next level in Pascal triangle. 3 choose 2. 3 choose 2 is 2 times 1. Okay, 3 times 2 is 6 over 2. You get 3, which is correct. Okay, the coefficient is 3 itself. So basically, what this slide is trying to tell you is that you do not need, okay, to memorize all these numbers. So don't go 121, 1331, 14641. No need. Okay, if I use the NCR, okay, this is a way for me to generate the Pascal triangle without me having to memorize all these coefficients. So again, no need to memorize. This way will actually help me to generate. But I think to help you to put it together, okay, what we can do is to give you the general idea of how we can generate for 1 plus b to the power of n. Okay, so for 1 plus b to the power of n is this n choose 0, b to the power of 0, okay, which is just 1, okay, plus n choose 1, b to the power of 1, b to the power, then n choose 2, b to the power of 2. Okay, notice that b is increasing, okay, with power. Then the next one is b to the power of 4, b to the power of 5. Okay, not to worry. I know it's like a, b, n and all. Okay, it seems quite difficult. Not to worry. It's just a pattern. Okay, I will just show you the pattern now. Then we can do this together. So now, the question states, find the first three terms in the expansion of 1 minus 2x to the power of 5. So it's 1 minus 2x to the power of 5 for example 5. So the first term in this expansion will always be 1. So the first one that I write, see how the pattern goes, is 5. Okay, so 5 choose 1. Then after that we get negative 2x to the power of 1. So this one and this one will follow. Now, the next term will give me 5 choose 2, negative 2x to the power of 2. How I get 2? Is 2 here. This is the third term. Okay, if you want the fourth term and fifth term, I just write it out for you so they can see the pattern. There's no need to do this. The next term will actually give you 5 choose 3, negative 2x to the power of 3. Then plus 5 choose 4, negative 2x to the power of 4. There's no need to do this. That's why I wrote it in red, but I just want to write it out for you so that you know how the numbers come about. Similarly, for 1 plus 3x to the power of 9, first term is 1. Then we do what choose what. Okay, think for a while. Okay, if you follow the pattern from above, first one is 9 choose 1, 3x to the power of 1. I follow the 1 here. The next term is 9 choose 2, 3x to the power of 2. Then I will write in red color. You don't need to do because they ask you for the first three terms, but I just want to show you how the pattern works. 9 choose 3, 3x to the power of 3, plus 9 choose 4, 3x to the power of 4, and so on and so forth. But the terms in red do not need to be written down. So what I'm going to do here is this. Okay, I'm going to erase this and erase this. If I simplify, all right, 1 is just 1. Okay, 5 choose 1 is 5. 5 times negative 2x. You need to figure out how to use your calculator to find these values. Like 5 choose 1 is actually 5. And then negative 2x, you leave it alone, it's negative 2x. Do remind me in class, okay, to show you how to use your calculators to achieve get the value of 5 choose 1, 5 choose 2, and so on and so forth. Okay, for example, 5 choose 2 itself. The 5 choose 2 is 5 times 4 is 20 divided by 2. 5 choose 2 value is 10. Then negative 2x times negative 2x is positive 4x squared plus dot dot dot. So this simplifies to 1 minus 10x plus 40x squared. Okay, similarly for the second one, 1. 9 choose 1 is 9, then times 3x. 9 choose 2. 2 times 1 is 2. 9 times 2, 18. 18 divided by 2. This value should be 9. 3x times 3x. 3x squared is 9x squared. So what I get here is 1 plus 27x plus 3 to 4x squared. Just like that. Okay, now, hence, find the expansion, or in the expansion of this, find what the coefficient of, find in the expansion the term in x squared. So now what we'll do here is this, okay, slowly, okay, so we take the two terms, okay, I'm just going to add another page here, okay. So what we have done in the previous slide is we have 1 minus 2x to the power of 5 and 1 plus 3x to the power of 9 itself. So what we can do here is this. What I'm going to do is I'm going to try to show you 1 minus 2x to the power of 5 is 1 minus 10x plus 40x squared plus dot dot dot, okay, and 1 plus 3x to the power of 9 in the previous slide we've done in blue color is 1 plus 27x plus 3 to 4x squared plus dot 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 dot. Okay, now they say that they want up to a term in x squared. So whatever you can get x squared and below, we try to multiply. The rest just leave it alone. So for example, 1 times 1, still okay. It's until x to the power of 0. Then 1 times 27x, x to the power of 1. Yeah, we need that. 1 times 3 to 4x squared until the term x squared. Yep, we need that. So what I'm going to write here is 1 times 1 is 1, 1 times 27x, and 1 times 3 to 4x squared. Then what we're going to do is we look at negative 10x. So negative 10x times 1 is negative 10x. Yep, still required. Then what we do, negative 10x times 3 to 4x squared. Negative 10x times 27x, you get negative 270x squared. Yep, until the term in x squared, we still require that. It's good. Now, negative 10x times 3 to 4x squared. This times this will give you a term in x cubed. So, do we need this term? Notice, right, that the question only says that we want until the term in x squared. So, this multiplication here is not required. So, we just leave it alone. Then we go again to the next term, 40x squared. So, just now I did the 1. I did a 10x, okay, but I stopped for this one, basically generated a term in x cubed. So now if I look right at the x squared term itself, this times this is good, okay, it's term in x squared. This time this is term in x cubed, I don't want. So 40x squared times 1, 40x squared times 1 gives me plus 40x squared. Then 40x squared times 27x will give me a term in x cubed. Do I need that? Once again, I don't need that because they only want until the term in x squared. So I will just stop right here. Now I start to collect terms. 1 is by himself. There's no other like terms. Then 27x minus 10x will give me 17x. Then 3 to 4x squared minus 270x squared plus 40x squared. Use calculator, I will get 94x squared. And that is that for example 5. Okay, now I invite you to try 5 now. Okay, this is actually similar to what we have done earlier. So, in try 5, if I have expanded 1 minus 6 to the power of x, so what you should check is that you should get 1 minus 6x plus 15x squared. You should be able to get this. 1 plus 4x to the power of 7 will actually give you this term here. Then if I multiply these two expressions together, and I want a term in x squared. So the 1 multiplied to the 1, the 1 multiplied to the 28x, the 1 multiplied to the 336x squared, that's what I require. Negative 6x multiplied to 1, negative 6x multiplied to 28x is still a term in x squared. The third one, they'll give me an x cubed term. I don't want this. Lastly, 15x squared times 1, that's good. 15x squared times this will give me a term in x cubed. I don't want this. So I only go until 15x squared times 1, which is here. Simplifying should give you 1 plus 22x plus 183x squared. Okay, example 6 is the last example. I won't dwell too long on certain parts of the working. For example, if I were to expand 1 minus p to the power of 5. So I'll start with 1 plus 5 choose 1 negative p to the power of 1 plus 5 choose 2 negative p squared plus 5 choose 3 negative p cubed plus 5 choose 4 negative p to the power of 4 plus 5 choose 5 negative p to the power of 5. No more. Okay, once you reach 5 choose 5, you will stop. Then what we get is 1 plus 5 times negative p. 5 choose 2, 10 divided by 2 is 10. So it will be 10, okay, times p squared. 5 choose 3. So 5 choose 3 will give me 10 times negative p cubed plus 5 choose 4. Okay, I'll get 5 p to the power of 4. 5 choose 5 is 1, negative p to the power of 5. Simplifying, I get 1 minus 5p plus 10p squared minus 10p cubed plus 5p to the power of 4 minus p to the power of 5. That is part 1. Now, for part 2 is something similar. Okay, so I've expanded 1 minus p to the power of 5 here. So what I need to do for part 2 is I'm replacing p by x minus x squared. So I want to do it for the term as far as x to the power of 3. So now if I replace p with x minus x squared, I replace p with x minus x squared. Okay, I just replace this one. Okay, then I replace p with x minus x squared, and so on and so forth. Okay, so what happens here is this. If I start to expand, all right. Okay, so if I start to expand here, what I get is 1 minus 5x plus 5x squared. So this expands to this. Now the next term is plus 10. No need to expand everything. X minus x square down here, I just focus here. I get a square minus 2ab, so it's minus 2x times x squared gives you x cubed plus x to the power of 4. That part I no need because we only want to expand as far as a term in x cubed. Next one even easier. The first term will be x cubed. Okay, the rest of the terms, okay, will give me something greater than x cubed. I just ignore it already. So I just put, right, for this term here, I just put x cubed. Then the rest of it we can just ignore. If I expand everything, what I get is 1 and minus 5x plus 15x squared. This and this will give me 15x squared, and minus 30x cubed plus dot 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 dot. Okay, for part 3, okay, I will leave it alone, and then I will just stop here for today. So just I know it's quite a bit, but do try your work right in class.